to be talking about developing effective project plans for SRE interns. I've been involved with our intern program at Facebook for many years now, and I'll be presenting all my accumulated wisdom in the next 4 minutes and 45 seconds. So you're getting interns, that's awesome. SRE, as you know, is a field that you don't learn in a school, so you have to learn it on the job. It's a mixture of coding, systems, problem solving, networking, everything else. That means it's tough to teach, and we learn it in practice. So what makes a good intern project for SRE? One of the things we like is something experimental. So for example, maybe you have a rewrite an existing service in Rust, and if it doesn't work, well, you still have the old one, so that's good. Or maybe you have something greenfield. So for example, like write a new service that is doing some traceroute and analyzing traceroute data. Well, if it doesn't work, well, you never had it in the first place. So, wow, I'm ahead of time here. All right, so we want to always seek to maximize intern interest and impact when you're developing a project plan. When interns are motivated, when they're excited about what they're doing, and they will know if the things that they're working on are impactful or not. They will know if they are doing something that you're giving them it's BS, right? Always make your interns ship something. If they know that they're going to have to ship something by the end of their internship, that's going to motivate them a lot harder to work and to be effective. So don't give them, little crap tasks to work on. Combine code and operations. So one mistake that we've made in our intern program sometimes is giving interns that were projects that were too coding heavy. And then they finish their internship and they're like, well, why am I not just a software engineer, right? So you want to combine that operational work, but not too much operational work, because otherwise they're just operational slaves, and they don't like that either. So that's not good. You want to give interns a real sense of SRE work and have them enjoy it. Wow. Talking so fast, I'm ahead of my slides. So I think a really good marker for an intern project when you figured it out is like, would you want to do this project? If like any good project plan that I've ever written up, by the end of the time I've written it up, I've been like, wow, this sounds really cool. I want to do this. Like, why am I giving this to my intern? But I think that's a good sign. All right, now onto the template that we use for project plans. First thing is a title and description. Be clear and concise. So here's an example of a good and a bad project plan title. Very important, because that's what their intern's gonna, that's the first thing that your intern's gonna think. Second one is skill requirements, and I think you really need to be honest about the skills that you're gonna need your intern to have or to learn while they're doing the project. So it's also a great way to match interns with projects that they might wanna do for you. Emphasize, though, it's very important. This can be what interns learn during the summer. I can't tell you how many interns have come to Facebook not knowing any C++, and like 12 weeks later are like pounding out professional quality C++. They can learn really, really fast, especially when they're motivated. So don't think this just because they don't know it, they can't learn it. Number 3 is you need a risk section. What could go wrong? There's all kinds of risks that could go wrong, especially like an internship is usually like 12 weeks, or 3-4 months. It's not a lot of time. And how will you deal with that risk if it happens? So what will you do? Do you have a plan to mitigate the risk? Do you have a plan to work around it? Change the project plan. It's very important to think about these things up front, because a lot of things can go wrong, and they will. Number 4 is milestones. So interns, they're usually coming from university. They're used to getting assignments, like from their professors, like, do this, hand this assignment in, do this. You need to compose the work for their internship in the same way. So having these examples of very specific design and production goals that they're going to have to achieve by a certain date is very important. Obviously, they can change. You may be flexible, but having that is very important, especially up front. And then finally, you need some extensions and ideas for project minimums. So like, what if your intern is killing it? Like, what if they're just way more productive than you thought? Or what if the project turns out to be way more complicated than you thought? How can you make it shorter and smaller, but still ship something, or make it bigger and extend out the work in some way that gets even more cool stuff done? All right, wow, I'm talking really fast. All right, so to recap, have a written plan. Get the written plan peer reviewed. So we peer review our plans just like we peer review our code. Number 3, make the intern ship something. Like, even if it's not exactly what you thought they'd ship, make them ship something. They'll feel a lot better about it. And then do it again next year. So thank you very much for helping to grow the next generation of SREs.
Hello, I'm Swati and this is my colleague Vrinda. We both are production engineers at VMware, and today we are going to talk about how we migrated our services across Kubernetes cluster with zero downtime.
Hi. Uh, so flights give me anxiety, and so does migrating services. And these two things are very similar, more similar than you would have thought. Uh, I'm going to show you how these two are similar using some memes. So most people have nightmares about plane crashes. I have nightmares about prolonged downtime. Specifically during migration, maintaining SLAs can be very tough. Even more tougher is like minimizing the risk during transition, right? So uh, at the end of the day, I don't want something like that to happen to me, right? I am also talking very fast now. These clusters can be spread across multiple regions and have different cloud providers. This should not pose a problem, not like having two connecting flights back to back does. Services should also be able to talk to each other, no matter where they're situated, which cluster, which region. That shouldn't make any difference. I shouldn't get a network out of range the way that dog did. Migrating any service, whether it is stateless or stateful, should happen seamlessly without making an SRE's job seem like an impossible task the way that meme does. So now that you've understood our problem statement and our obsession with memes, let's try to look at our solution. Swati is up.
You were really fast. So we have developed a Go-based Kubernetes controller, migration controller, and with help of Kubernetes annotations, we'll help understand how this migration of services is done with an example. Suppose we have two clusters, source and a target Kubernetes cluster, and we have this migration controller installed on each of the clusters. The two clusters are connected with a VPN so that the pods across the clusters have different IP addresses. So let's say we created namespace 1 in the source cluster. This migration controller will automatically replicate this namespace in the target cluster and also label it with replicated true, so that we know that the namespace is the replicated one in the other cluster. Let's say we deploy pod A in the source cluster and we expose it with service A. The migration controller again replicates this service to the target cluster, and both the services which actually be pointing to pod A in the source cluster. So any external request will be served by pod A from either of the clusters. Also, let's say we want to migrate now pod A from source to target. If we directly delete it, we might face some downtime in the service. So what do? We annotate source cluster with union, and we deploy a new pod in the target cluster. Hence, the endpoints are updated, and now any request can be served by any pods in both of the clusters. Now, you can see we have annotated target cluster with source annotation, which automatically makes the source service annotate with receiver. Hence, now both of the service endpoints will be pointing to new pod A, and we are good to go and delete the pod A in the source cluster. And now you can see we have seamlessly migrated pod A from source to target without any impact on the external request. As well as we have maintained the SLA for our services. We also might have sometimes requirement. We actually don't want some services to be migrated across clusters. We have developed an annotation such as singular, which will help us preventing the services to be migrated to other clusters. Let's say some stateless service with DNS. Also, to summarize this, the connection between the Kubernetes cluster can be set up. You need a tunnel like AWS VPN. Then the pod IP should be different across the clusters, as well as the Kubernetes API server for each of the clusters should be reachable from either of the clusters.
We have also updated our Kubernetes cluster from 1.3.5 all through 1.13.5 versions basically, and using this service. So, and it happened completely seamlessly. So, thank you. You can reach out to us at the emails here.
Yeah, if you have any doubts about the migration. Thank you.
Hi everyone. My name is Raushaniya, and have been working as SRE on Google Maps for over 3 years. GeoSRE works with more than 30 teams around the globe. So the SRE-Dev relationship is like any other relationship. It requires continuous active management. In my opinion, there are 3 core principles, or steps, if you like, that together compose a good recipe to ruin your SRE-Dev relationship. The first one, not understanding each other's responsibilities. When I just joined Google and met my developers for the first time, I asked them, okay, how I can help you? To which they replied, well, frankly speaking, we don't know what you're supposed to be doing and what we can ask you to do for us. So what we can do as SREs to fix or prevent that? Tip number 1. Write down SRE responsibilities and share them with devs. Communicate clearly and early in the process that SRE focuses on the same end goal as developers, which is make users happy, but we approach that differently. Our responsibility is to find that balance between feature deployment and reliability of the service by using error budgets and SLO. Tip number 3, get involved in design development as early as possible. That will make launches go much smoother for both sides. On to the second principle, which is not trusting. There is a saying, a relationship without trust is like having a mobile phone with no service. And what you do with a mobile phone with no service? You play games. From a SRE perspective, it's easy to think that developers don't care about end-user experience. But chances are they do. They just don't know how bad the service is or what they can do about it. On the other hand, developers might think, oh, well, SREs are just being obstructive. They don't see the value that we can bring, and hence they don't trust things that we ask them to do. So what we can do as SREs to fix or prevent that? Tip number 1, show your genuine willingness to help by scheduling a meeting with them and asking about all the pain points they're dealing now at the moment. Tip number 2, gain their trust by easing their production pain. Often enough, there are low-hanging fruits, and by fixing them, you can bring immediate and visible benefit. For instance, maybe they have a very slow and manual release process they're suffering from, and you just happen to know this automation in place that can tremendously help them. So why not to set it up? Tip number 3, put developers on call, so they could see for themselves what actual level of service you're providing. If you have customer escalations constantly, it is a clear sign it's time to focus on reliability. On to the last but not least principle. Can you guess which one is that? Not collaborating. Question to SREs in the room. Do you know what priorities your developer team has for this quarter? And are you sure that your developers know about your priorities for this quarter? If the answer is no to any of those questions, chances are there is a problem. So what we can do as SREs to fix and prevent that? Tip number 1, plan things you want to work on this quarter together with your developer team. It will help you to align your priorities and not to be surprised in the middle of the quarter thinking, wait a second, why are they working on that thing when this thing is much more important? Plus, without involvement, it's hard to ask for commitment. Tip number 2, set up regular meetings with them. It could be bi-weekly, it could be monthly, just to stay updated, to ask each other questions, to offer help to each other. Over-communication is better than under-communication. To revise, there are 3 core principles for a healthy SRE-Dev relationship. First one, understanding each other's responsibilities. Second, building and maintaining trust. And the third one, collaborating actively and continuously. Thank you.
Hi everyone, my name is Jay Chin. I'm from Grab. For those that don't know, Grab's like the Uber of Southeast Asia. Okay, so what does an SRE do at Grab? We do lots and lots of different things. There is so many things that we do, like coding, postmortems, incident response, monitoring, lots and lots of stuff that it's so hard to keep track of all this workflow coming in. So we had to find a way to optimize our workflow on how we can deal with our own personal projects as well as things that come from our clients. That's very important, as what the previous speaker had said. So we tried Scrum. Well, that didn't work for us due to the nature of Scrum and the amount of ad hoc requests that we get per day. We also tried various variations of Kanban, Scrumban, which is a combination of Kanban and Scrum. But we finally settled on our own modified version of Kanban. And I'm here to talk to you about what we did with Kanban and how we optimized Kanban to suit our workflow. Hopefully that will be helpful to some of you here. What we did was to have 3 different boards. As you can see, we have the main projects board, and we split up all the engineering requests that comes to us into another board. And we have a triage queue. This is where all the urgent stuff comes in. This is, I have to do it today or yesterday, and it needs to be done immediately. And those are the 2 workflows that we have. So we have SREs picking stuff off the triage queue, which is the really important stuff, and then going to the project queue or the engineering request queue. Those are prioritized every week, and then if there's nothing there, which is unlikely, they'll go back into the backlog and pick something up. This seems to be working for us. And I'll explain a bit about the main project board. This is where all the initiatives go, the product spikes, the upgrades, automation, things that we do as a team. Other teams are not allowed to create tickets in this board. This is our personal board. And it's important to limit work in progress. If it's one thing that you get out of this talk, it's limit work in progress. That is, you don't want to have an engineer assigned to multiple tasks. And this is the second board, which is the engineering request board. This is where we get all the requests from engineers and application teams. And we call this the toil board, which is toil work. The goal is to remove this board altogether. We want to automate everything on this board. And to do that, you need to categorize, quantify everything. See where the problems are coming from. See where the toil is coming from, and work to reduce all the tickets on this board by automation. That's the key. Come on, next slide. This is really a toil board. Come on, toil board. Let's go. Right, and use an interrupt shield. This is the biggest hindrance to an SRE team. Everyone pinging us on Slack because we solve the most problems. People coming to our desk. Designate someone from your team to be an interrupt shield, right? You can rotate that person. Usually it's once a week, but they take all the interrupts. This frees up all the other SREs to do useful stuff on the project board, automate stuff on the toil board. That's what you want to do, an interrupt shield, right? This is a picture of our actual board at Grab. As you can see, there's the project board on the left, and we have our engineering request board on the right. We also have red items, which is the must do it yesterday stuff. We also have a small section down there where engineers can place, okay, I want to use this. Let's talk about this ticket during our team meeting or during our architecture meeting. So this is the actual board that we use at work, the 2 physical Kanban boards. Final tips, there's no one size fits all. I hope you get some things that you can implement in your team. But you need to adapt and try to adapt. You can adapt like Kanban columns to suit your workflow, business processes. One really useful feature of Jira as well, that you can have a print feature. And this prints out all the small cuts that you can stick on the sticky notes and use it on your board. You don't need to write it, right? And also limit the number of stickers on the columns. This limits the work in progress. Once again, thank you all for your time. Enjoy.
Hi everyone. My talk will be basically about 5 actions how to train your team, your SRE team. So usually when you get a new project, it's pretty common that your team is not fully proficient with the technology stack that you have to handle. My name is Dorian Basuyau, basically. I'm working at Ubisoft Singapore, and we basically helping deploying the infrastructure for games, for mostly online games. And in order to be efficient as an SRE team, you need to keep up learning. You need to establish a good sense of trust in your team. There's always new technologies, new processes. We've seen some talks about postmortems, and postmortems is actually a good strategy to learn, to put this mindset in your team. So that will be the main message of my talk today. And well, we have a first action really is like, you need to establish a safe place to learn. Like your management team, your directors and so on, they need to make sure that, okay, we need to learn, we need to also bring projects that are very, I would say like not very easy also for intern or things like that, but you need to take some action to be basically, to give them opportunity to try new things. And your action too basically would be, when you have established this good trust relationship with your SRE team, with everybody, you need to know them. You have one-on-ones to help that, but it's not only a good thing. Like basically in our organization, we established some, we created a tool where you have thousands, literally thousands of technologies, where each SRE can self-evaluate themselves, and you have data. Thanks to this data, you know better where we are as a team, and you will have to make sure that it's not related to a performance review, because basically if it's like that, like you losing basically this sense of trust of your team. And when you have all this data, basically, what do you do with that? So it will be the action 3, where you can basically set your technology focus. So what we do basically is like we select between 15 to 20 technologies in our teams, and we'll put basically all our investment on top of that. Like, let's imagine like you have Terraform, you have Kubernetes, and well, it's in our list obviously, but your training strategy will basically support your business strategy. So like that, you have more engagement in your team, you have more engagement from your board of directors and so on, and you will be able to push that toward that direction. And on action 4, basically, it's like, thanks to this focus, you can create some technology, some training work groups. So the idea is like, what we do is like, okay, we have these technologies. You appoint one of your SRE, like your senior SRE, and he will lead basically this training initiative. Very good thing, like as we said, as we heard actually in the talk, when you have leading without managing, well, it's a good opportunity to push that sense of leadership in your SRE team. And also, you have your team more engaged like that, because learning alone is not always fun. Sometimes people have better abilities to do that. And the last action is basically just have to track your progress. And what do you do basically is like, you go back to the action 2, where you have this nice web tool where you can self-evaluate again your SRE. You do that, let's say, every 6 months or every year, and normally you see some progress if you have done all this action. And you can celebrate also this success like that. And basically, yeah, that will be actually the last session of my talk. Thank you.
All right, so my name is Mark. I'm a site reliability engineer at Stack Overflow. I joined in 2015, but these days I mostly work on our product, Stack Overflow for Enterprise, which is a private version of Stack Overflow that we can run for you in a cloud provider, and it keeps all of your proprietary code questions private. And the way that we do this is we take a full copy of Stack Overflow, the real Stack Overflow that you know and love every day, and we deploy them in isolated cloud environments. And to do this, like most people, we do it with Terraform. Now, if you're not particularly familiar with Terraform, essentially it's a way to define your cloud environments in code and then just deploy them repeatedly and reliably every time. So the way that we've done this is we have a Terraform module called Stack Overflow for Enterprise, and whenever a new customer comes on board, we take that module and we deploy it on whatever the latest version is. But you can't keep the customers on that same version forever because the code changes and the requirements change. And so the typical life cycle of a Terraform module goes like this. You start with your really basic version, maybe like one web server, one database server, and then you throw in a web application firewall, and then a customer asks for some Elasticsearch. And you throw all of these things in, and maybe you depreciate a feature and you remove it, and Terraform takes care of all of that for you. But then one day something outside of your control happens, and if anybody works with the Azure Terraform provider, you may know what's coming. They depreciate things in your provider. And what that means is, for example, your web application firewall that you have in there used to be defined in this one very rigid way, and they change it and they say you can't define it this way now anymore, you have to define it a different way. Now, Terraform's way of dealing with that, it looks in the state file, sees that something has changed, and then it goes, oh, that's not right, and it wants to delete it and recreate it as a new resource. But these are production systems. We can't be doing that. We can't be deleting things from production just to recreate them. You also can't define it twice, once under the old way and once under the new way, because then you end up with conflicts and recursion and all sorts of problems that occur that way. But the good news is that this is not a new problem to be dealing with. Database administrators have been dealing with this problem since the dawn of time. And the way that they deal with the difference between the schema that you have in your code and the schema that exists in your database is with a simple migration routine. Now, Terraform has no concept whatsoever of a lateral migration like this. But the good news is that we're SREs, and we have tools. We have our CI/CD pipelines, TeamCD, Jenkins, GitLab runners, all that sort of stuff. We have our programming languages. We have shell scripts, PowerShell, Go, you know, you name it, we have things at our disposal to do it. So I don't have a huge amount of time to go into the detail of exactly how we built ours and run ours. But essentially what you need to do is you need to approach migrating your Terraform the same way you would approach migrating a database. So you have the version of the Terraform module that you are currently running, and you have the version of the Terraform module that you want. Now, in some cases, these could be 6 months worth of development that you're rolling up all at once. And so what you need to do is you need to have a routine that knows about all the differences that you need to do in your state migration. And these are the same way that a SQL migration would run. For example, somebody makes a change, they make a list of what they changed, and this could be a Terraform state RM command, it could be a Terraform import command. And you can, instead of just doing a Terraform plan and updating the module, updating your module number, doing a Terraform plan, and then doing a Terraform apply, you need to run it through your migration routine. So in this case, we have a PowerShell command called update TF module to version 0.4.5. It looks at the version that was in there and then runs Terraform state RM to forget something, or Terraform state import to replace something with the newer version, and then runs the new version of Terraform plan, and everything comes across smoothly, and you end up with a consistency between your Terraform state code that you've written and what's in your Terraform state file. So the bottom line to this is essentially that you just need to treat your Terraform migrations and your Terraform modules in the same way that you would treat your database migrations, and at the same time you also need to back them up. Thank you.
Hello everyone, my name is Amiya and I'm a founder of Squadcast. For those of you who don't know about Squadcast, it's a platform that helps you adopt SRE best practices and kind of make sense of all of the noise around SRE that everybody's talking about. So I'm talking about transparency and incident response, right? And this is really like what happens in most of the organizations. You know, the list of people that you trust is very, very small. And this is just Sev 1. For Sev 0, there's probably no paper even in there, right? So the idea is that you want to trust people, but, you know, and trust begins through understanding. Now, in a lot of organizations, there's a conception of reliability through obscurity, because the ideas of security and reliability are almost always conflated. And in security, you have like access control, authorization. So you want, a lot of people don't even have access to a lot of observability metrics. But really, reliability through transparency is the best way to do things, because it helps you improve your metrics, improve your processes, and also helps everybody understand kind of what transparency, what metrics you're really tracking. So there are really 4 levels of transparency that you can think about. The first level of transparency is internal. So engineering team, you have like probably status pages that are gated just for the engineering team. And by engineering team, I mean like everybody who's not technically challenged, right? There's the next level of internal transparency across the entire org, product teams, business teams. You have SLOs that your business teams are supposed to understand. The next level of transparency is where you expose your incident management practices and your SLOs to external stakeholders like your customers, vendors, or anybody that you're working with. And the next level of transparency is where you really bear all. You know, you take it and it's kind of like, you've seen companies that actually live stream outages, and that's I feel like that's the holy grail of transparency that they've gotten. And that's really a state where you know, you can feel very confident about being in a place where your metrics are constantly improving because you're being transparent about them. And for various metrics and events, you want to choose what kind of transparency you want to go with. Like for some things, you just want to have it at internal transparency, A, you know? So you can choose where do you want, which level of transparency you want certain metrics or certain SLOs to be at. Now, transparency is really central to SRE. You know, choosing SLIs, SLOs, it's like part art, part science. We all know that, you know, we probably don't choose the right SLI oftentimes. So if you really reveal this information across your team, so it's going to be easier because people will be able to understand, you know, whether these SLIs are the right SLIs or not. Then if you're transparent about your SLOs, you also have a better understanding of dependencies across these SLOs. You could form better policies around error budgets and how these SLOs kind of interact with each other. And this is really like, what I want you to take away from this is, you know, for every organization, you need to think about transparency in a more deliberate fashion, and you need to think about, okay, if I have a metric or if I have an SLO, what level of transparency is it going to be at? Busting some myths about transparency. Just because you're transparent about something doesn't mean that other people get to have a say in it. It's just that you're communicating what you're doing to people across the organization. So it's not decision by committee. There's still, you know, probably only a few people that get to have a say on that. Explaining my SLOs, so people feel like, you know, things get really complicated if you have to be transparent about SLOs, but that's not really true, because if you want to be transparent, you want to make it really simple that folks, you know, who are even not techies can understand. There's another myth that if you're transparent about everything, things get complicated because everybody has to understand stuff, but it's actually twice as fast because it removes all the blind spots in terms of the metrics that you're sharing. Benefits of DevOps and SRE transparency, you know, this is some of the things that, you know, you could probably get if you follow a transparent culture in your SRE organization. So at Squadcast, actually, we have, you know, this loop of you know, doing incident management in the SRE way. And this actually helps you kind of develop operational transparency across your org. And you can choose like different levels of transparency for different metrics and events that you have. Lastly, you know, this you can try out Squadcast. Shameless plug here. Sorry about that. But you can try it out online. We have a coupon code for folks who are listening to this talk and whoever you want to share it with. So also, we're right outside, so if you guys didn't get a t-shirt yet, there's a really cool SRE t-shirt, so please come by the booth and grab one. Yeah, that's pretty much it. Thanks.
Hello, my name is Andreas. I've been with Google for about 1.5 years, and I used to work for a company with maybe, well, it was a larger company, but our team was a dozen developers. We had a couple of dashboards. It all worked fine. Then it came to Google, and whoa, a couple more dashboards. So how do you get there? The first part is, as most people probably heard by now, define your application SLO. The SLOs that we have are not necessarily actually defined. They can be explicitly defined. They can also be implicitly defined. So if your service is actually running for 5 nines, but you defined 3 nines, and then all of a sudden it goes out, your users will actually complain because they expected 5 nines. They had 5 nines in the past. Collect those metrics, define those SLOs. Now that you have your SLOs defined or SLIs defined, you can specify your metrics for those, collect them, and eventually you'll have a couple of dashboards. Dashboards show graphs. The graphs are useful for looking at what you actually have there. Well, obviously dashboards. The problem with the dashboard is now your SLO failed, you get breached. And what happens? This is a useful dashboard? Not necessarily, because it only shows one thing, it's your application SLO. One problem is SLO breaches, it shouldn't be on a dashboard, it actually should be an alert, so somebody actually runs and does something about it. If they look at that dashboard now, all they see is, oh yeah, my SLO was breached, which they already knew from the alert, so it doesn't really help. If you actually go to the doctor because you have fever, the doctor measures your temperature, tells you, hey, you have fever. It's not exactly world-breaking news. You already know that you have fever, so you need somebody to actually, or something, more metrics to dig into this, which means that you need metrics for all your dependencies and everything that you depend on, which also means more dashboards in order to get in there and figure out what's going on. So just an SLO dashboard is a bit useless. You need to instrumentalize a lot more on your service side. Yeah, that's one part actually. So now you have your dashboards. The question is, how do you get to more dashboards or to more metrics? In Google, we have a lot of services, literally thousands of services, and they run on thousands of jobs. The best way to do that we managed to do is actually standardize on metrics, meaning on metrics name, on metrics meaning, get them into our standard, well, on our time series database, and get them then you can get them out of there as well in a standardized way. Standardizing doesn't just mean standardizing on your metrics, but it also means that you can standardize on instrumentalizing your frameworks, meaning that if you have an RPC framework, for example, then you can collect everything that uses that RPC framework automatically. It's pretty cool because you keep the developers from thinking about instrumentalizing their code. They just have to use the framework, and well, lo and behold, they actually get metrics for it. Once you have the metrics, we can collect them horizontally, and then you can create the dashboards for all of these. The reason usually, or at least in my old company, basically the application owner had to do all the dashboards, which doesn't really scale up to a lot of services. So at Google, we actually have the service owners and the framework owners do all the dashboarding, which means that they know best what actually is collected for their dashboard, for their framework and services, and B, you only get one dashboard for one service. Well, not necessarily one dashboard, but a collection of dashboards for their services. Now, we have a possibility to surface those dashboards, and the application owner can now dig into their dependencies and figure out what the dependencies are on the other side as well to see what their problem is, why their SLO was breached. We do this, we manage to do this also automatically because we have a little bit more information on the metric side. So the metrics actually have metadata attached to them. So we know that if an application uses a framework or a service, we automatically surface dashboards for that application as well. This leads to another problem on our side, that some of our services now have hundreds of dashboards. How do they find the right dashboard that is actually useful for their metric? We started to experiment with this a little bit. So basically the A is everybody or all the dashboards and all the metrics that exist within Google. The user has to define a scope, which is kind of their range of work that they're interested in. And from there, they can drill down into their dashboard. We're still working on this, but yeah, we hope that we have a solution for that soon. Thank you. Wow, that's a lot faster than I expected.
So I have a diversity story to tell. So what SREs can learn preventative paradigm from moms. So that is a diversity story. So I work as a director of engineering at Salesforce, based out of Hyderabad office in India. And standard disclaimers apply. Opinions are mine, not my company's. Okay, so at Salesforce we have a tradition to start with a thank you. So I want to thank the program committee for giving me the opportunity, and all the SREs here at this conference, and the SRE community at large for all the learning and sharing of best practices. So about the topic, so how moms nurture kids with preventative paradigm as a theme, underlying theme, right? It has some lessons for SREs to learn when we build and scale and run these distributed systems. So that is preventative by design. So how moms really help nurture happy kids from food to play to health. So reliability is one key aspect of nurturing kids, right? So effective monitoring. So moms monitor kids effectively before they get into trouble. So you need to prevent before they get into trouble, and then if they get into trouble, how to monitor them, the basic parameters until they recover fully. And they are on the front line reacting to situations, and then they also keep track of what they are allergic to, and what they like, what they don't like. All these things, moms do good job in ensuring that the reliability is an important aspect of while nurturing kids. And so moms are basically letting the kids go out into external environments like schools and playgrounds. So they're embracing risk. Kids can get into trouble, right? So they're embracing risk by letting them go and play and grow. And at the same time, when they get into trouble, how they ensure that they don't get into more trouble by keeping them at home, or don't letting them go and play, or don't send them to school. And then also raising them in a healthy environment with instilling good values. So that's that's integrity aspect of security. And the scalability is basically growth is an important aspect of nurturing kids, right? So and then how from food to play and their health, taking care of all that. At the same time, having healthy conversations with them if they are feeling down, if they are not doing well at school, or they're not playing well, so blameless RCS, right? So helping them, what they're good at, what not, that without blaming them. At the same time, they also keep a schedule of all the vaccines and their birthdays, all the events, important functions, all that is like config management aspect of the scalability. So performance is basically how they manage their schedules, balancing the schedules of the schools and play, and how they keep the schedules tidy, and then at the same time get them more organized at home, at school, and do their the exams and all that. Okay, eliminating toil, and then also continuously help them learn, and then teach them and mentor them for a better healthy human being. Yeah, that's a performance. So if you look at, they are basically how, if you look at all these things, it's preventative by design. Okay, they're not letting kids get into trouble. They are preventing that before something bad happens. So by managing all these schedules with them, and health and food and play. If you really look at what also happens is sometimes you have to balance the priorities. If you're an SRE for a large site like Amazon.com, so during shopping season, your priority is on scalability, and other times it's all about security. Okay. So it's diverse viewpoints that we bring to the SRE. That's how this profession can benefit. So SRE needs more women engineers. That's the point. Thank you.
Oh, sorry. Hi, I'm Daisuke from Tokyo, Japan. I'm working at the microservice platform team at Mercari. So today, okay. So some of you might be thinking, what does delegating ownership mean? So at first, let me explain about our background about the migration to microservices from monoliths. So Mercari has been started with monolith architecture. It was good at first, but we found that it was not scalable against the growth of our service and organization. The complexity of code base increases, and the speed to ship the new features to our customers slows down. So we thought that we needed to change the system and organization before we grow up more. So we started to migrate to microservice architecture to scale our organization and maximize the organization's output. So by using microservice architecture, we can organize small, autonomous, and cross-functional teams. To realize this, giving end-to-end responsibility, strong ownership to microservice teams is important. Okay, so microservice team are expected to write code and deploy it and run it by themselves. With monolith application, a centralized team has the responsibility to deploy and run. But it's not good for hundreds of microservices. So we started to delegate these responsibilities to microservice teams. So the first question is how to prepare a microservices infrastructure. A microservice team has a responsibility to set up the infrastructure for their microservices by themselves. To simplify the provisioning and encourage infrastructure as code, we prepare a new environment to manage all infrastructure, microservices infrastructure using Terraform. We are using a mono-level strategy to reduce the cost of setup CI/CD and apply the common policies. Platform team manages the CI/CD script and provides common Terraform modules. And microservice team can review and merge by themselves only for the changes for their microservices. They don't need to ask review for centralized team every time. The second question is, what are the microservices requirements in production? Most of the developers are new to having the mindset of SRE, so they have to run it to be confident to run their microservices. So we prepare a production readiness checklist. This checklist contains requirements of production microservices in Mercari. And all microservices must fulfill this list before production rollout. Not all microservices have to follow the strictest rules, like most important microservice. So we prepare 3 levels based on the SLO of microservices. This checklist contains 8 aspects, and each aspect contains multiple actionable checks. For example, reliability includes the existing of auto-scaling. So we manage this all production readiness checklist on GitHub issues. At first, the microservice team create an issue from the template, then fulfill it by themselves. At the last, before production rollout, architect team and platform team review it. And we are planning to implement an automated readiness checker and run it periodically to check continuously. In this talk, I talk about why delegating ownership to microservice team is needed and how we do it. We are still in progress to migration to microservices, but these practices are contributing to organizational expansion with microservices. That's all. Thank you.